A single note on the violin is beautiful on its own. In the universe, even the smallest units of life, known as atoms, have their own unique orbitals as well, where negative charges known as electrons reside. But individual notes from our sheet music can transform to create a piece like box air on the G string. To understand how molecular orbitals form, it's important to understand superposition. Now, let's get introduced to the z-axis. We define it as the axis along which a bond forms. Well, let's take it back to the piano. Suppose you play two notes, C and E, and you want to combine them. Well, you have two possibilities again. It's either the chord of a dominant major scale or its relative minor scale. Atoms or molecules in which the electrons are paired are known as diamagnetic. Those that have one or more unpaired electrons are paramagnetic. The transformation can be described by the wave function. Wave functions are mathematical descriptions of where an electron is likely to be. Imagine two waves that meet. They can either add up and form a bigger wave, which is known as constructive interference, or bonding orbitals. They can also cancel each other out, called destructive interference, which form anti-bonding orbitals. Suppose the energy level diagram is similar to the one of dihelium, which is basically a non-existent molecule. In fact, its energy as compared to one of the strongest molecules like O2 is so minuscule that it makes sense. Well, bond order is calculated by taking the number of electrons in bonding orbitals minus the number in anti-bonding orbitals and divided by 2. So now that we've learned that everything has two possibilities, I guess we don't really know whether I'll win this challenge or not. But we can choose to have science impact our lives every day. So keep learning and keep creating.